Hello everyone, Assalamu alaikum. Welcome back for another video in the lab series. In this video, we will learn how to extract a layout from a given schematic. For that, I'll be using an example of a two input NAND gate. So first I'll draw the schematic of two input NAND gate, and after verifying its functionality, I'll draw the symbol and then I'll show you how to extract the layout given your schematic. Now, Virtuoso Layout Editor XL is a schematic driven layout generation tool. To learn schematic driven layout, we will create the schematic view of a two input NAND gate first. So I'm giving these parameters to my NMOS and PMOS in the circuit. So now your schematic looks something like this. Now we have to ensure that our NAND gate performs according to the given functionality. So all we need to do is again perform that transient analysis that we did in previous labs. So I'll launch ADEL and simulate the design to verify its functionality. For that, I'll set up model library as usual, and analysis type and outputs to be plotted as we have already done before. Now the difference from the previous lab and this lab is that in the previous lab it was inverter based lab, and an inverter only has a single input, and for this one you have two inputs. So in order not to get confused or not to generate same outputs, what we need to do is while we are setting the signals, input signals for A and B, we have to use different periods and delays for the two signals. You can provide these periods, or you can also change these periods and see what your output looks like. I just need to make sure that both A and B don't have the same periods, and they don't have same delays, so that I can ensure the functionality of my gate. Also, I need to make sure that 0 to 1 and 1 to 0 transitions for both input signals do not occur at the same time. Now after setting all these parameters, let's just simulate the circuit, and your output can be something like this. I just need to ensure that my NAND gate works uh, according to the given truth table. Everything seems fine so far. Now once that schematic is complete, we need to create a symbol for that as well. So like I drew the symbol before, I'll try to make the symbol for this NAND gate. So before moving forward towards extracting the layout, I need to create layout views for body ties. And for that, because these body ties are used in each circuit, so I'm just going ahead and making these and saving these layouts so that I don't have to make them again and again for each circuit. So just follow along. So we'll make two instances for body ties, one for p type p sub and one for n type n well. Now for that we'll create a cell view, and we will fill out the form as follows. I'm naming it m1 underscore p sub so that I know that it is metal to p type substrate. Now we'll draw the substrate p-type substrate contact in the same way that we made in the previous lab as well. All I'm doing is making sure that my dimensions are correct and then saving it accordingly. Now once I have this p-type, I just need to copy it and change the p imp layer to n imp layer, and everything else remains the same for the n type substrate, and that's it. Now I can use these for each circuit every time I draw the layout for each circuit. Now returning back to our original NAND gate, what I need to do is I need to extract the layout using this layout extraction. I need to extract the layout using this layout XL tool. So in the schematic editor window, we need to execute launch and then layout XL. This window will appear. Just click OK, a new file will appear. You just need to type the layout and then layout editor window will appear like you have seen previously. All you need to do now is just execute connectivity and then generate all from the source. And the following box will appear. Go to the IO pin section and the dialog box shows that all IO pins are in metal 1 layer. So ensure that this is selected. Also put a tick mark on this create label as label. Click options and set height as 0.1. After that, click OK. The initial pin and transistor placement in layout will look something like this. Now it can be out of the box. You can see the border here. Let's just change some options here. Just click on options and display and click on these options. Fill out the form as we have done previously as well. Now you can actually see the transistors. Now what that layout extractor tool did was just extracted the pins and the PMOS and NMOS transistors, but we still need to connect these. So you can see that it is not a fully automated tool. You can extract the layout, but you still have to connect each PMOS and NMOS transistor according to your given schematic. Now, the transistors and pins are shown inside this bounding box, which is an estimate of the optimum size of this final layout. Automatic router will use the bounding box to constrain all the routing to occur within the box. The bounding box may need to be resized to accommodate all the components. This is an important concept to keep in mind during resizing, is that standard cells typically have fixed height. We don't really necessarily need this bounding box right now, so you can delete it as well or expand it, whatever you want to do. Now Virtuoso layout editor XL and this GPTK090 allows us to create stacked transistors with shared source and drain areas. All you need to do is zoom into two transistors at the bottom or at the top first, so whichever you like. Because you have to merge both of them together. So click on the transistor and move this object. As you start dragging this object towards the other transistor, fly lines indicating connectivity will appear, as you can see. So when the source or drain areas are overlapped, just click left click and this will fix this position. You can see that both of them are stacked together. This was done for NMOS for NAND gate. As you can see, the source drain contacts have disappeared. Now let's do the same exercise for PMOS as well. The PMOS transistors in NAND gate do have shared drain contacts, but they work in parallel. Connectivity information is extracted from this schematic by this Virtuoso Excel. Now the pull-up network looks something like this. So you have your pull-up network ready and your pull-down network ready. All you need to do is make connections and add the taps, grounding taps. Now connect different layers using this path tool. The path tool can be activated by pressing P on your keyboard. We will fill areas by drawing rectangles where necessary. Okay, so to connect one layer to another, for example poly to metal 1 or metal to metal 2, we can create via by pressing O, as you already know. So a practice that you can follow while wiring is to use metal 1 for all vertical wiring and metal 2 for all horizontal wiring inside the cell. Now your final layout will look something like this. Okay, that's it for this video. If you found this video helpful, make sure to like, subscribe and share it with your friends. And if you have any comments, just leave it below in the comment box and I'll see you in the next video.